Hi, Math 30-2s. Today we're just going to carry on with logical reasoning and set theory, and today we introduce the idea of Venn diagrams. Okay, so Venn diagrams, if you haven't seen them or heard of them before, are basically a visual aid, okay, or visual representation of sets of data and the elements, okay, that are in those sets and how they relate to one another. So just as kind of a review from last day, okay, what it says is that we basically learned about connecting words, okay, and the connecting words that we learned were and, or, and not. We will use those words again today to look at how sets of data interact with one another, what they have in common and what they do not have in common. In this lesson, we will continue to use these connecting words when we introduce Venn diagrams as a visual aid in illustrating the relationship between sets. Okay? So, as a review, it says the following is taken from class example 2 of the last lesson. Okay, so this is what we took a look at in lesson 2. It said consider the following two sets which are subsets of a universal set, and the universal set, okay, that we're talking about here are natural numbers that are less than 20. Remember, natural numbers start at the number 1 and are whole numbers from there. So 1, 2, 3, 4, etc. And here they're just asking us to consider those natural numbers, but only up to 20. The first set, okay, is basically A, which are natural numbers less than 20 that are divisible by 3. Okay, and then the other set was set B, natural numbers less than 20 that are divisible by 5. And again, notice that both of those sets are represented by capital letters and contained within curly brackets or braces. Okay. Now it says, using the appropriate notation, list the set of whole numbers less than 20 that are divisible by 3. So again, the important point there is that they want us to use the appropriate notation, and I'll make sure that we are discussing that as I go through each question. Now in A, divisible by 3, okay, they're nice. They put the capital letter A there for the elements that are in that set. So the natural numbers less than 20 that are divisible by 3, and again, this is what we did last day, 3, 6, 9, 12, and then just because I run out of room, I go underneath here, 15 and 18. Now, normally I'd want to write all that data straight across in a line, but again, because of the limited room here with this question, I just go underneath, okay? But I make sure all of those elements are contained within the curly brackets or the braces. Now in B, they want all the natural numbers divisible by 5 that are less than 20. So again, when I notate it properly, I put a capital letter B, okay, equals, and then the curly bracket. So those numbers are 5, 10, and 15. Again, all values that we saw last day. In the third one, now divisible by 3 and 5. Okay, so those numbers, again, when they use the word and, have to belong to both groups. So with this, it would look like this. A, there's the symbol for and, B. Okay, so that's the appropriate way to notate it. So A and B is equal to, and the only number that belongs to both groups, okay, is the value or the number 15. Okay, so that's it. In the fourth one, divisible by 3 or 5, so there's that connecting word or. Again, I notate it properly. So A, there's the symbol or notation for or. B is equal to, now again, remember in or, we are discussing the values that are inclusive, meaning they can belong to one group or the other group or both. So basically when we see or, we want to just put all the values that are in 3 and 5 divisibility. So I combined set A and set B for or. So everything in those two groups combine, because if I pick a value from either of those groups, it's divisible by 3 or 5 or both. Okay, so when I combine those groups together, I get 3, 5, 6, 9, 10, 12, 15, and 18. Okay, so you'll see that that is set A and set B combined together. So again, nothing new there, just a review from last day, review of the values, what natural numbers are, how to notate those sets properly. Okay, now we're going to take a look at what that looks like when I represent it visually in what we call a Venn diagram. So it says Venn diagrams. The relationships between set A, set B, and the universal set U can be illustrated visually in what we call a Venn diagram. So if I take a look at the Venn diagram they've drawn to the right here, you'll see they have the letter U right there, which stands for the universal set. Okay, so that's natural numbers less than 20. And what they do is they contain all the information inside this rectangular structure here. Now, we always want to draw that, okay? It's not an option to draw it, we draw it, okay? That meaning all the universal information is going to be inside of that box, that rectangle, okay? So that's the first thing. Now it says the elements of each set are marked with a dot. So what they're saying here is that because I'm talking about the actual numbers themselves, 1, 17, and 4, okay, there's a 1 with a dot, a 17 with a dot, a 4 with a dot. That when you have dots after the numbers in a Venn diagram, that refers to the actual number, okay? If we have numbers in a Venn diagram that do not have dots, that refers to the number of items. So I would have 1 item or 17 items or 4 items, like 17 computers, 4 computers, etc. In this case, I'm talking about the actual number 1, the actual number 17, the actual number 4. So that is notated by them having dots, okay? So that's a key point there. Make sure that we understand that and that you do that moving forward, okay? And that's what they say there. We mark them with a dot to distinguish them from the number of elements in a set. Now, notice the following points. The number 3 and 5, okay, is located in the intersection, okay, which is the overlap of the two circles. So that's right there in the middle of the Venn diagram. That's usually the key piece of information when we're discussing Venn diagrams. We want that middle piece of the diagram, and then usually you'll see with the problem solving questions, it's easier to figure out the other parts of the diagram from that piece. The second one is the number 3 or 5, divisible by 3 or 5, are located within both circles. So anything inside of A or B, okay, will be included in or because it belongs to one group or the other or both. Okay, so anything inside circles A, B, in this case, set A, set B, is considered or. And then lastly, the numbers in the universal set that are not in set A or set B are located in the rectangle but outside the circles. So again, that's your 1, 17, 4, 7, 14, 13, 18, 19, 16, 11, and 2. Okay, those are all the numbers inside the universal set, but are not divisible by 3 or 5. Okay, now what we're going to do in the next little bit here is just do some shading, okay, and talk about these key terms that are bolded. So in the first one, okay, they asked me to shade in the Venn diagram the intersection, okay, so intersection is another way of saying A and B. So again, remember, and has to belong to both groups, so the area of the diagram that belongs to both groups is that area in the middle there. So when you see intersection or A and B, then we are discussing the center of those two circles where they overlap. In B, okay, the word we use is union, okay, and union refers to or, so A or B. So that's going to be anything in circle A or in circle B, okay, so like this. Anything that is inside either of those circles. Again, just to reiterate, or does mean inclusive, so it means circle A or circle B or both. Okay, so those two circles combined. And then lastly, we talk about the complement. Okay, so the complement of set A, and we read that as not A. And if we had to notate it, it would look like this, right? A prime, okay, with a tick there. So that is how we notate the complement of A. So basically, when we do these questions, we think about what A is, and then I want everything except that. So if I picture shading in A, okay, picture circle A totally shaded in, everything else is what I'm going to actually shade in this question. So everything except circle A, okay? Do not shade inside circle A at all. Everything else we are shading and filling in. So that's what the complement of set A, what we call not A, looks like. Okay, so hopefully those are making sense, and we're just going to move forward, do some similar questions on the next couple of pages. Okay, so consider the following two sets from the review on the previous page. So again, they stick with the same two sets, set A and set B. Okay, and again, A referring to natural numbers less than 20 divisible by 3, and B natural numbers less than 20 divisible by 5. In each of the following Venn diagrams, okay, shade the region that is represented by the set, describe each set in terms of A and or B using connecting words, and then determine the number of elements in each set. So again, they want to know how many elements are in each set. So some of the work has been completed as a guide. So the first one they start for us, they want me to shade set A. Okay, they've done the notation for me, just A. And again here, NA means the number of elements in A. So the first thing I would do is figure out what I'm discussing. Well, they want A, so that's everything inside of A. That's the 3, the 6, the 15, the 9, the 12, and the 18. hopefully you can see all of those values or numbers are inside circle A. So as a total, there are 6 of them. So the number of elements in A is 6. Now, I haven't shaded it, so what I would do is I was just showing you by circling them, but I would shade in that circle. Okay, so that's what I would be after in that question. In B, they want me to shade set B. So, okay, I notate it with just B. They also want the number of elements in B. So again, NB stands for the number of elements in B. So this time, what's inside circle B? Well, 15, 5, and 10. So that is 3 elements, and then I would circle or shade, sorry, okay, everything inside circle B. So there you go. There's set B. All right, shade set and then not A, or the complement of A, okay, is what they are looking for in this one. So again, we just did what A was right above that question. So the complement of A is everything except A. So again, I want to shade everything except those values that are inside of A. So I'm going to shade everything except what is inside circle A, like so. Okay, so there's the shading for the complement of A, or not A. And then I count the number of values that are in that shaded region. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so there are 13 elements that are not in A, or are the complement of A. Next example, again, what does that mean? Okay, well, that is the complement of B, okay, or not B. And then I want to know the number of elements that are not in B. So again, right above this question, we shaded what B was. So the complement of B is everything except circle B. So I shade everything except for what is inside of circle B, like so. Okay, that's what we are after there. So again, now when I count up those elements, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, there are 16, okay, elements that are not inside of circle B. Okay, so these questions get just a little progressively more difficult as we move through them. Now we are talking about A and B. So again, I have to know that this notation, or that symbol, refers to and, okay? So A and B, and again, if you remember A and B, okay, those are the letters we're using here, those are the sets. It has to belong to both, so that is just that value there, 15. So there's only one element that belongs to both. Next, okay, they use the other symbol or notation. This stands for A or B, okay? So that notation is A or B. And again, or is inclusive, so as long as it is inside one of the circles, okay, we want to consider it. Now the notation here, or for the number of elements, would look like this. The number in A or B. The number of elements in A or B. So when I shade, it's everything inside those 2 circles. Okay, that's A or B. So count them up. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 elements that belong to set A or B. Okay, next page. Now, this is where they get a little trickier, okay, because we're talking about the complement of sets and in conjunction with sets that are whole. So, for example, okay, in the next one, notice right there, okay, we have the complement of A and B. Okay, so when I write that down, I would say I want not A and B. So I want to know where not A and B overlap. So you want to kind of envision in your head what not A looks like, and you want to envision what B looks like, and then you want to shade that common area. This is the number of elements in not A and B, okay, like so. Now, what I can do is I'll do this first one in 2 colors, and then hopefully you'll be able to see how we end up with our final solution here. So first thing I do is I shade not A. All right, so I shade everything that is not A. Okay, so that would be not A. But I also want that and where B overlaps. So if I shade now circle B, okay, there's me shading circle B. So the values that overlap, those 2 shaded, the blue and the red, okay, the area that overlaps is right there and right there. So there are only 2 values right there. So if I get rid of everything else, okay, you'll see, okay, that is what we are after there. The shaded region that I have right there, okay, is not A and B. Okay, that's what we would be going after. In the next one, okay, this time I want A and not B. Okay, so this is A or not B. Okay, so that's the way I would write it out. So I would say A or not B. Okay, that's what I want. Then I want the number of elements in A or not B. So again, when we use the word or, it's inclusive, so it can be in A or not B, or if they do overlap at any section. So visualize shading in A, then visualize shading in not B. Okay, so that's going to actually end up being the opposite of what we just had in the previous question. Okay, so when I shade in A and then not B, where they overlap, there will be 17 elements. Okay, so the shaded area that they would overlap, okay, would look like this. Okay, so this is basically the shading in of A or not B. Okay, that's what we'd be after in that question. Next, this is not A and not B. So not A and not B. So there's me writing it out in words or explaining it. Now I want the number of elements in not A and not B. Okay, so it has to belong to both not A and not B. So you would shade in your mind not A, then shade not B, and visualize where they overlap. So when they overlap, okay, what you're going to get is everything outside of those two circles. Okay, that's not A and it's not B. So count up the number of elements there and you will get 11. Okay, next, not A or not B. So they've written that in there, not A or not B. Number of elements in not A or not B. Now it can be one or the other or both. So this time when I shade, okay, it's going to be everything except that very middle value of 15. That's the only thing that doesn't fall into a category. So when you think about it, if you pick any number there inside the shaded region, it will be not A or not B, okay, or it could be both. So count up the elements there and you will get 18. Okay, so there are 18 elements there that are not A or not B. All right, next. Now, the placement of the brackets here, okay, is important. This is A and B, not that. So in this case, you want to find what A and B is and then everything except that. So we know that this is A and B, isn't it? Right in the middle. So in this question, I find A and B and then the complement of that. So everything except that. So if I go and shade, I actually want everything except that middle section. Okay, so like I said, the placement of the brackets there is important. So there is not A and B. So again, I write it like this, not, and then in brackets, A and B. Okay, now when I write out the number of elements, it'll be the number of elements in A and B, okay, not that, or the complement of that. Okay, so again, when I count those up, I will get also 18 here. Okay, next one, this is A or B, not that. So think about what A or B was, and then I want the opposite of that. So again, they've written it out not A or B, then I would want the number of elements in A or B, not that. Okay, so A or B would be the two circles fully shaded in, so I want not that, so it's going to be everything outside of those two circles. Okay, so in that case, the number of elements is 11. Now at the bottom here, they're saying, as demonstrated in the previous lesson, we can see from the above Venn diagrams that not A and B is equal to not A or not B. So that was that one there. And not A or B is equal to not A and not B. Okay, so sounds confusing if you can remember that. But what they're really talking about here is in these two questions, these values and these values, okay, and diagrams end up looking the same, as do these two. Okay, so that's what those two starred points at the bottom of the page are representing. Okay, so let's move on to some questions that basically show a little bit more problem solving, and then we'll have some discussions here about what's important moving forward and what you need to make sure you're able to do. So it says use the Venn diagram to list the elements of the following sets. Now again, what I noticed in this question before I begin is there's U, the universal set. Everything is contained inside that rectangle, and the values also have dots. That to me again means I am dealing with those actual numbers, not 7 elements or 2 elements or 11 elements, okay? Not the number of items. These are the actual numbers that I'm talking about. So it says use the Venn diagram to list the elements of the following sets, P. So when they talk about P, okay, they want everything inside circle P. So when I look inside circle P, these are all of the values that are inside circle P. So I write them down, right? I write down 1, 2, 8, 9, and 10, okay? 1, 2, 8, 9, and 10. Now, they don't have to be in numerical order like I did there, but a lot of times that's the way they will be listed, okay? Now for Q, so again, everything that is inside of circle Q. So that would be 1, 7, 10, and 29, okay? So there are the elements for set Q. In the next one, they want P and Q. So we know from the shading of the diagrams we just did, P and Q, and they're just using different letters this time as opposed to A and B, are where the two sets overlap. Okay, so that's right in the middle, 1 and 10. So I list the elements for P and Q, which in this case, 1 and 10. Okay. P or Q, again, we know from the shading of our previous Venn diagrams, or means inclusive, so that's anything inside the two circles combined. So that's going to be 1, 2, 7, 8, 9, 10, and 29. Okay, so those are all the elements that are contained inside those two circles. All right, moving on, not P. So again, when I want not P, I visualize what P looks like, and then I want everything except that. Now, we actually figured out what P was in letter A, so I would want everything except what I found in A. So again, if you want to do it by listing of the numbers, that's great. If you want to use the Venn diagram and the visual representation, that works as well. So visualize what is inside circle P, and then you want everything except that. So those elements would be 7, 11, 16, and 29. Okay. Next, not Q, so same basic idea or principles. Visualize everything or take a look at everything inside circle Q, okay? And then I want everything except that. So everything except what I circled, because what I circled was Q. So that would leave me with 2, 8, 9, 11, and 16. Okay, so that is not Q. All right. Now, the more complicated ones, okay? Not P and not Q. So it cannot be P and it cannot be Q. So think about not P and not Q and where those two areas would overlap. Or I can take a look at the two previous questions I did, E, not P, not Q, and find the numbers that belong to both of those groups. Because remember, and means it has to belong to both. So when I do that by either using the Venn diagram or by using the list of numbers up above, then I will see that 11, 16 are the only numbers that belong to not P and not Q. Now, not P or not Q. So again, or just means it has to belong to one group or the other, okay? Or it can belong to both. So remember with or, we basically combine the two groups together. So what I would do is I would combine E and F together from the previous questions, okay? Because that's not P, not Q. Or when I take a look at the Venn diagram, I would shade not P, I would shade not Q, and it's anything in those two areas combined. So that will leave me with 2, 7, 8, 9, 11, 16, and 29. Okay, good. Now, moving on. So same thing here. The placement of the brackets here is very important. This is not P or Q. So I would figure out what P or Q is, and then I'd take the opposite of that. So in this question, again, I figured out what P or Q was in letter D, or you can think about P or Q. So that would be the shading of anything in P or Q, and then take the opposite of that. And what that would leave me with is just 11 and 16. Okay, and then the last one, not P and Q. So again, what I would do is I'd figure out what P and Q is, and we know that that is 1 and 10, and then I do not want that. So I would want everything except 1 and 10. So that would be 2, 7, 8, 9, 11, 16, and 29. Okay, so now it says which two pairs of sets are identical. So again, you can see that G and I, okay, have the same values, and that was what we actually starred at the end of the last page. And then you should also be able to see that H and J are the same, okay, and H and J, okay, and there you go. Next, Venn diagrams can also be used to represent the number of elements in each set and not the individual elements, as in the next class example as it illustrates. The numbers in the sets are not marked with dots. So when we are not marked with dots, and we talked about this already, they do not represent individual elements, okay? So for example, in these questions just below here, when I see the number 12, 3, and 7, that's not the number 12, the number 3, and the number 7. That means in the case of this question, that's 12 students, 3 students, 7 students, okay? So that's how we distinguish the numbers themselves from the number of elements we are talking about. So let's read this question and see how we do. The diagram displays the number of students who are members of student council, so that's the circle S, and the number of students who are on the yearbook committee, okay? That's inside circle Y. How many students are on student council? So when I take a look at student council, okay, that's S. So how many students are in student council are basically inside of circle S? Well, I have 12 students that are only on student council, but then I have these 3 students that are student council and yearbook. But those 3 are still on student council. So when I do that calculation, it would be the 12 students that are only on student council, plus the 3 students that belong to both student council and yearbook. So there are 15 total students that are on student council. Okay, next, on both student council and yearbook. So that's like saying A and B, okay, or in like the last question, P and Q. So when they say and, okay, they're focused on that number in the middle, aren't they? So that's just the number 3 right there. Okay, next, on yearbook committee, but not on student council. So in that calculation, you want to know the ones that are on the yearbook. So here's circle Y. So on the yearbook, but not on student council. So everything inside circle Y, remember, is yearbook, but I want to get rid of the ones that are also on student council. So in this case, it's 7. So that's the number of students that are only on yearbook. Okay, and then finally, on student council or yearbook committee. So this is like saying A or B, P or Q, in this case S or Y. So remember, with that calculation, it's anything inside the 2 circles altogether. So that would just be 12 plus 3 plus 7. Okay, so that's going to give me a total of 22 students, like so. Okay, so those are the types of questions where they give you the Venn diagram, okay, and then you're answering questions based on the numbers provided. These questions will also make an appearance in your homework and on tests where you have to draw the Venn diagram, okay? So let's take a look at this. So it says, in a homeroom of 20 students, 15 take math, 12 take social, and 10 take math and social. Show this information in a Venn diagram. How many students take neither math nor social? Okay, so lots of things going on here. I know that I am dealing with 2 subjects, math and social, okay? So I am going to draw 1 circle for each of those subjects, okay? And again, here's mathematics, here's social studies, okay? And then I will, whatever I end up doing here, okay, I'll make sure that all the information is contained inside this universal set, okay, or this box rectangle that I've drawn. Okay, so there's kind of the scenario. Now here are the key numbers, okay? There are 20 students in the class. There should be 15 in the math circle, 12 in the social circle, but here is the key point, okay? 10 take math and social. So that number goes right in the middle, okay? And that's what I had talked about earlier in this lesson, is that that's the key value that we're after, that middle one if we can. And here's why, okay? So I now know 10 take math and social. That value goes in the intersection of the two. If I work my way backwards, okay, they're now telling me 12 take social, right? So that means there should be 12 students in the social circle. But there's 10 right here, so that means I can only have 2 that take just social studies. Mathematics, there's 15 students that take math, but 10 of those take both, so that means there are only 5 students, okay, that take only mathematics. Now, when I add 5, 10, and 2, I get 17, but there were 20 students in total, so that means there are 3 students on the outside of those 2 subjects or circles, but still in the universal set of the homeroom. Now, I have to make sure I always go back and read the question that they're actually asking, which in this case is how many students take neither math nor social. So in this case, you want the number of students that are not in either of those circles, and that is the number 3, okay? So 3 students do not take either math or social, okay? So 3 students is your answer to that question, okay? Hopefully that made some sense. All right, now, the more complicated ones look like this, okay? In a survey of 400 households, there were 285 that had personal video recorders, which they refer to as PVRs, and 320 that had multifunction printers, MFPs. 63 did not have PVRs or MFPs, okay? So here they go with telling us what is what here. Let P represent the number of households with PVR. Let M represent the set of households with an MFP, and let X represent the number of households that have both a PVR and an MFP. So if you notice in the write-up of that question, they never gave me that middle piece of information that I was after, but they're saying, well, let's just represent it with a variable X, okay? And that's what we do in any question when we do not know what the middle portion is, or the intersection of those two. I just put an X or an unknown variable there. So A says mark X and 63 in the appropriate parts of the Venn diagram. Why? Well, why the number 63? Well, again, that was the number that did not have either PVRs or MFPs. They are still part of the 400 households, but they didn't fall into either circle, so 63 goes on the outside. Okay, so there is X in the middle to represent the number of households that had both, and 63 goes on the outside of the circles, but still inside the rectangle, okay, the households that had neither PVRs or MFPs. So that's part A. Now, B says write an expression for the number of households who have a PVR and not an MFP. Write this expression in the appropriate part of the Venn diagram. So that have a PVR, okay, so that's going to be in this circle, PVR, but not an MFP. So I want to get rid of the ones that basically had an MFP, so that's going to be these in the middle, which we refer to as X. So they said that there were 285 households, okay, that had PVRs. So this circle, or this section, would be the 285 minus X, okay, minus the number of households that had both. When I go to the next circle, okay, which is going to be M, and those are the households with MFP, okay, the number that had MFPs, okay, were 320, but I subtract the X. I subtract that middle section, and that will tell me the number, okay, of households that had just MFPs. So if I go back to the question, they wanted the expressions, so I put them in the diagram already, but it's 285 minus X, and then for the next one, it would be 320 minus X, okay? So that's pretty important that I know how to get those expressions, okay, because that'll lead me to part D, where it says form an equation in X, which just means using the variable X, and determine the number of households in the survey who had both an MFP and a PVR. So when they want both MFP and PVR, that's the variable X. That's the piece right in the middle. Okay, that's what we're after here. So how do I do that? Well, I have to add everything in the Venn diagram together and make it equal 400 because that was the number of households that were surveyed. So here's what I do. 285 minus X. There's the expression for the number of households with just a PVR. To that, I add the number of households that had both. To that, I add the number of households, okay, that had MFPs only, and then I have to also add the number of households that had neither, and that will equal the number of households surveyed, which is 400. Okay. From here, I remove the brackets, so 285 minus x plus 320 minus x plus 63, that will equal 400. Now, when I get my numbers together, okay, on the left-hand side, I will get 668 minus x, and that will equal 400. Now, again, I'm after x here. So what I do is I go 668 minus 400, okay, equals, take x to the other side, which is what I'm after, and you will see that you get 268 that equals x, okay? Now again, x was the number of households that had both, and that's what they were after in this question. What you have to be extremely careful of is that they won't always be asking just for x. They might ask for the number of households that had just PVRs. If they asked for the number of households that had just PVRs, you would go 285 minus 268. If they wanted the number of households that only had MFPs, you would go 320 minus 268. Okay, so once you find that middle piece, don't always assume that's what they're after. Read the question carefully, and once you do find that middle piece, you should be able to answer any question that they throw at you, because they're really going to look for the middle or one of those two areas, most likely inside the circles. Okay, so once in a while they'll ask for the number of, for example, in this question, households that had neither. But once you find X, that middle piece, okay, you're good to go. So just read the question carefully. Okay, so hopefully